For the vectors. So easy to read. I think that's what, 6, 2 and negative 3, 3. So this is a continuation of the previous one. But notice in this one now, we're finding the magnitude of those vectors. So from the previous one, 3 vector u plus 4 vector v, we found down here to be 6, 18 in component form. Is that okay? So by finding the magnitude of 3 vector u plus 4 vector v, so in component form with 6, 18, how do we find the magnitude? Yeah, for the most part. So the magnitude would equal the square root of each component squared. So we would get 6 squared is 36, 18 squared, I don't even know. It ends with a 4. That's all I got. I think it starts with a 2, but I'm not sure. $364? $324? $324 plus 36 makes, oh, look how nice that is, 360. What's the square root of 360? How does that clean up, I should say? Yeah. 6 square roots of 10. Good. All right. So to do the next one, so we have to first find what 7 vector u minus 5 vector v is in component form. So if vector u is 6, 2 in component form, then 7 vector u, let me pick a different color here. Would be 42, 14. Is that okay? Just multiply each of the components by k. And negative 5 vector v would be what? If only there was printouts. 15, negative 15. So to find 7 vector u, you multiply the component form of vector u by 7. So 7 times 6 is 42, and 7 times 14. Cool. And since we're going to find 7 vector u minus 5 vector v in component form, since we individually found the parts, we could just add these together. So what's the component form of 7 vector u minus 5 vector v? So 42 plus 15 is 57. And the vertical component would be negative 1. So to find the magnitude of 7 vector u minus 5 vector v, what's the setup? Of? Yeah. All right, I'll do the hard one. What's 57 squared? $2,500 plus 49 plus 114. What? 3,000 plus 1 is 3,250. So how does 3,250 rationalize, or clean up, I should say? Because at least it has 25, which is a perfect square. So we know we can at least pull out a 5. 5 square roots of 130.